Hello everyone, welcome aboard. This video is basically going to cover all the database concepts. So if you are a beginner and want to pursue a career in being a DBA or a DBA developer, so you can start with the very basics of the database concepts that will help you to have a base ready on top of that, which you can build a building as in how you need it. So without further ado, let's get started. So we're going to start with the very basics of the database concepts. And when we talk about database administrator work or database concepts, the term that we use again and again, and the term that we should be asking ourselves is database. Like, what is a database, right? So yeah, that's a cute picture out there of a database. Basically, a database is a collection of information organized to provide an efficient retrieval. So the collection of data, and it is stored in an electronic format in a computer, in a computer. Like we're gonna talk about how things get understood by a layman. So it is the collected information that could be in any number of formats. It can be an electronic format, it can be a printed, graphic, audio, statistical combinations. So there are physical and electronic database. A database could be, say, for example, as simple as an alphabetic arrangement of names in an address book or a phone book. So to better understand what a database is, consider a telephone book for an example. If you have the telephone book stored on a disk, the book would be a file. Within the telephone book, we have a list of records, right? We have the name, the address, telephone number. So these single piece of information in this book would constitute a separate field while you are dealing with the databases. Because a database can store thousands of records, and it would be tedious if we have to go through each and every page or the record to find the desired information, we have an option called the database queries. Yes, you got that right. So we don't have to go through database records in the tedious way. Rather, to retrieve data within a database, we run a database query, which is an inquiry into the database that returns the information back from the database. So like, in other words, you can say like a query is used to ask for information from a database. So a database can have thousands of records where many fields per record. For example, a telephone book would have your name, your number, your address, and so on. So in order to get the desired information from the database, it may take a fast computer a significant amount of time to search thoroughly the whole table, the whole database in order to retrieve the data. So this is where the database indexes comes in handy. So when we think of an index as a layman, we think of a notebook where we have the index. So what does the index actually say? It says, for example, in a book, it would say the topic, the name, and the book number, the page number on which that particular topic can be found. So an index, in terms of a database concept, is a data structure that improves the speed of data retrieval operations on a database table, right? For example, if I need to look for the salary of an employee, John, I can use the index in order to find all the employee data. And that way, I do not have to go through all the details of the database. One of the major disadvantages of index is that they need to be created and updated, which requires processing resources, and it takes up disk space. Yeah, that's right. So just like how we maintain the indexes in our notebooks, it is the same with the databases. We need to keep them updated all the time. So these databases, now we know about the databases and the indexes, right? But where are these databases? So these databases are found on the database servers so that they can be accessed by multiple users and provide a high level of performance. One popular database server is Microsoft SQL Server, which many of you would have heard of. And database servers like SQL Server, they do not actually house graphical programs or word processing applications or any other type of application for the matter of fact. Instead, these servers are entirely optimized to serve only the purpose of the database itself. So these servers, they do not act as workstations. They generally are mounted on the racks located in a central data center and can be accessed only through an administrator's desktop system. These Microsoft SQL Server uses 3 types of files to store the databases. Primary data files, which have an .mdf extension, are the first files created in a database and can contain user-defined objects, such as tables and views, as well as tables that SQL Server requires from keeping track of the database. If the database becomes too large and it runs out of room on your first hard disk, you can create a secondary file. Yes, that's the second point. And these secondary data files have an .ndf extension, and they are on a separate physical hard disk. The third type of file used in SQL Server is a transaction log file. And these transaction log files have an .ldf extension. And these transaction log files, they do not contain objects such as tables or views. As the name suggests, transaction log file, it contains all your log data. We're going to go into much details with all these file extensions while we deal with it practically. So, as it reads, users do not have direct access to the databases. So now we know that what is a database? The database indexes. Where do these databases sit? They sit on a database server. But how do you actually get the access? How do you talk to these databases? So for that, we have a database management system, which is which is also known as like DBMS. A DBMS, what is a DBMS? It is a collection of programs that enable you to enter, organize, and select data in a database. So for example, a ticket agent may run a ticket system program on your hard disk computer that in turn accesses a ticketing database. All right. So these are the final users which use the client end applications in order to communicate with the databases. So these are the databases which are found on a database server. Now, the next is types of databases. There are basically 3 types of databases: flat file databases, hierarchical databases, and relational databases. Flat type databases are the simplistic in design, as the name itself suggests. These are like flat. They have 2-dimensional data. For example, look at this example. In this example, a simple flat type database, so it's a company, it's a supply company that has matched each customer with what he or she consistently orders for easy retrieval and reordering purposes. So we have an ID, we have the customer name, and we have the order. So why it is called a flat type dimensional? Because it has got 2 dimensions, and that's it. It only consists of rows and columns. Next is a hierarchical database. A hierarchical database is similar, just like a tree. In this database, each parent table can have multiple children, but each child can have only one parent. So we're gonna look up to this picture. So each row or record provides an employee's information, including his or her employee number. The child table holds the computer equipment data, and the employee number column links each record to the parent table. This is the parent table. It has got the employee number, the first name, last name, and the department number. And this is the child table, which has got the serial number, type, and the employee number. So which employee has got what type of equipment or instrument or whatsoever, any kind of order. A parent can have multiple child, but a child can have only one parent. So when you look up to the employee number in the child table, it says 100 in front of computer. So the computer is being owned by the employee whose employee number is 100. But he also owns a monitor, and the same employee also owns a printer. So that's a hierarchical database. And the most important and the most talked about database type is the relational database type. A relational database is similar to a hierarchical database in that data is stored in tables, and any new information is automatically added into the table without the need to reorganize the table itself. But unlike the hierarchical databases, a table in a relational database can have multiple parents. Let's just go back into the previous slide, where in the hierarchical database, a parent can have multiple children, but a child can only have one parent. But in relational database, a child can also have multiple parents. So the model number in the child table comes from the parent table 2, and the sales number in the child table comes from the parent table 1. The first parent table shows the salespeople within a company, and the second parent table lists what product models are sold by the company. Meanwhile, the child table lists customers who have purchased models from the company. And this child table is linked to the first parent table by the sales number and to the second parent table by the model. So let's continue with the database fundamentals. We have two pictures in front of us. One is the picture from a spreadsheet, the Excel sheet, which we work on a daily basis. And on our right-hand side, we have the picture from a database, and it's the output of a sales table and the purchase that we have done. So a spreadsheet is often the starting point for creating a database. So with a spreadsheet, it's easy to create headings and start entering data, right? Adding, deleting, reordering, and formatting headings is simple. And you can easily sort the data under one or more headings. It's also easy to insert, delete, and filter rows as per your desired requirement. But spreadsheets are designed for limited to only thousands of rows per worksheet. So a spreadsheet cannot hold the amount of data a database can hold. Moreover, when a spreadsheet is opened, the whole file is loaded into the computer's memory. So if enough data is stored, the file may eventually fail to load up due to insufficient memory. So why this shows that a database has an upper hand when compared to a spreadsheet, because the databases are designed to store billions of rows of data as compared to a spreadsheet. The databases are limited to the computer's available hard disk space, and they're optimized to use all a computer's available memory to improve performance. So as you probably already know, a spreadsheet can contain several worksheets, each of which stores logically grouped information in a tabular format. A worksheet is comparable to a database table, and the headings is comparable to the columns or the fields within a database. So yes, this is what we learned, why databases are preferred over the spreadsheets. So a worksheet column can contain data that might be blank, right? In such cases, a blank is stored as a null in the database. A database table can be designed to either allow nulls or disallow nulls within a column. So this is it when it compares to the database fundamentals. That's it for now, guys. In my next video, I would mainly be talking about the relational database management system. And if you like this video, give it a thumbs up. And if you want to leave any comment or any kind of suggestion for me, you're free to do so. Thank you so much for watching.